mystery item time, because I do not have a clue what this item is supposed to be. It was described on eBay while I was buying lots of similar things as mini diffuser, ozone, air purifier, air ionizer, ozone generator, home bedroom. I have tested this and there's absolutely zero detectable ozone. It shows, well, in the picture it's a bit sort of faded out, shows the little baby with the cleft lip and this thing beaming out purple beams and leaves and right, let's open it just to see what it is, but I'll give you a demonstration of it first, although it's not that exciting. Now, the first technical hitch I came across with this is it's got a little button on top. I thought this was going to be some rechargeable device. It is not. When I got it, I thought it won't be terribly high power. I'll plug it into this little power bank. The green light flashed, but when you press the button on the top, the green light just pulses and nothing happens. So I thought, oh, maybe it's too powerful for this. It kept flashing as well. That's because the button is jammed down. So then I got a more powerful USB power supply and I tried it again and nope, it kept pulsing. And then I got the bigger power supply again, a big black web one, plugged it in, activated it, pressed again, still pulsing, nothing happening. And at that point I was thinking, is it supposed to be silent? Is this what it does? So then I got an even bigger power supply, plugged it in, pushed the button, and it starts. So there's something drawing such a high current spike at startup that every single one of these power supplies cut out. But here's the odd thing. If I bring in a standard plug-in power supply with a USB power monitor on it, and I press the button, it can start it, but it's only drawing 142 milliamps, so that must be some big capacitor or something with a very high startup current. That's strange. Let's open it. Actually, before I open it, let me show you what it looks down the end of this. So I'm just going to pause and try to actually even get this to expose properly because it's not very bright at all, this thing. It's a sort of dull purple glow. One moment, please. Well, that's as good as I can get. The green LED is much brighter than what's going on there. There's a dull purple glow suggesting maybe ultraviolet. Let's open it up and find out. One moment, please. And we're back. Right, let's unplug this and explore it. So there's nothing obvious for getting into this. It looks as though it feels heavy. It feels like it's got a aluminium case. And this looks as though it's pressed up on the inside, so I don't think this is going to come off. And that kind of suggests that the bottom is going to come off here. And I don't think it's going to come off cleanly. Now, where's my spudger? I should have looked my spudger out before I even started. I've buried my spudger. There it is. But is that even going to work? It's certainly, the bottom is in squint. The bottom is in squint. Oh, this is such a tight fit. I think this has been wedged in. Am I going to have to drill a hole in this to try and get it out? Hold on, let's drill a hole in it. And then hope there's not a huge lithium battery inside, although I don't think there is. So let's lever a screwdriver in here and see if I can prise it out this way. Oh, that is in tight. It's glued in. Right, well that's not helpful. I think this is going to be a destructive experience. Maybe they just didn't want us in here. Maybe they're hiding something. Right, tell you what, one moment, I'm just going to pause and then I'll come back once I've kind of got this base out. Oh, this isn't good. Is this actually welded shut? It's got that sticky foam pad there that was holding the base on. Oh, nope, here it is. Oh, it's quite a arrangement. Oh, at least they've got an ionizer. I think that's all it is. And that's kind of bad news in a way. Oh, I suppose there's a carbon filter. Except the air intake's there, and it's blowing the air out there, so the carbon filter is doing nothing? What's that about? Right, okay. Quite a hefty construction in here. like welded into everything. This is bizarre. Right. So now get that off. This is going to wiggle loose, revealing the circuit board, revealing an ionizer module. This is bad news because ionizers create a high voltage with respect to ambient ground. Oh, and look, there's the ultraviolet LEDs, which are just UVA. They're not, well, let's power it up. Those are just single chip LEDs. Let's power this up. Let's unplug the fan so it's not running. And we'll see if I can get any indication here of, so I'll plug that in, turn it on. They're just UVA LEDs. So it's pretending to be the germicidal. I mean, there's this belief that UVA, and this is near UVA, it's like near ultraviolet, probably about 405 nanometer. I don't really see this being, usually you can smell something in vicinity. If I put it across my fingers like this, any degradation? Nothing. These are just ultraviolet LEDs, just for show. Okay. Right. But the ionizer, the problem with the ionizers, and that's kind of stuck up there. It's not a great way to do it either. The problem with ionizers is they create a high voltage to ground. So they're effectively, if you plug it into this power supply, the ionizer creates that high voltage respect to ground, but then you end up with a high voltage across the power supply, and it can actually stress the electrical separation in there. Okay, let's go further on this. It's like they have spent a lot of time making this, but it's kind of delusional design. Oh, it is quite odd design. Where's a little tiny screwdriver? There's a little tiny screwdriver. So they've got a little satellite ultraviolet LED just screwed on here with two LEDs in parallel and one resistor per two LEDs. There's a microcontroller. There's a little MOSFET that switches, I guess, everything on. And I'm guessing, is it the... So there's the circuit that's switching the light. There's the one that's switching the ionizer. And there's the one that's switching the motor. I'm guessing they're all in parallel. Well, let's take a closer look at the circuit board. One moment, please. I believe this is what Ave would call a treat spécial. And in a way it is, but for all the wrong reasons. This product is maybe a copy of someone else's product, and they've just missed everything. So here was the point, the filter. This filter in the base here was designed to have the air pull in through here, go through the filter, up through this hole, and then go into the fan, which is the wrong way round. But I guess maybe they could have used a fan that had the port on the opposite side, not sure. But whatever happened, they ended up with the grill here, so that's where they put the air intake instead of putting it down here where it could go through the filter. And that means the filter at the bottom does absolutely nothing, but there's no point anyway, because unless you could remove the bottom of the original product that this is possibly copied of, because if it had clogged up, you wouldn't be able to get into it anyway. The whole thing is basically just glued together. The little processor here, I thought it was actually cutting the power bank out by drawing a high current spike, and my thought was that it was a fairly powerful fan, but the fan is about 120 milliamps, but it could still start with a fairly high current. But watch this. Let's plug the fan in here. So we'll get the fan in here. We'll plug the ionizer into its little socket. The ionizer isn't referenced to ground, so not a great idea. The ultraviolet LEDs that are drawing so little current, they really are just a visual effect. They might have just used two. And we'll plug it in. And when I press the button, the green LED will start pulsing as if something's like cutting out. And I thought that was the power bank. So let's unplug the fan. No, it's still pulsing. Let's unplug the LEDs. Still pulsing. Let's unplug the ionizer module, which draws 24 milliamps in use, but must have a high inrush current. I'll just pull that connector right off. But oh, now it's staying on. So what if I plug in the fan? Fan's running absolutely fine. LED's running absolutely fine. Off, on, no problem. Plug in the ionizer. I'm going to have to be careful of this now. Oh, is this going to go back in there? And it instantly struggles. Cuts out. It's the ionizer that's causing the problems. That is very bizarre. And I think it's possibly caused by, well, let me show you this. I can bypass the MOSFET with a pair of metal tweezers. And everything runs, but every time I do it, you'll see that the LED glitches. It turns on, that's the processor resetting. And if I unplug the ionizer again, I could actually zoom down for this, couldn't I? I should have zoomed down for it. But if I unplug the ionizer again and bridge that out, I could bring on the loads, the other loads, and the processor doesn't reset. Okay, we shall investigate that later. It's all very, very strange. Let's bring in the circuitry, which initially looks quite a nice design. We've got the push button, we've got the microcontroller, we've got a little bit of supply filtering, which completely fails for the microcontroller, possibly because they've taken a negative here from the incoming supply over to the processor and given it its own local supply with that capacitor, but then they appear to have actually just then taken another negative right over to the main current path for the MOSFET, which doesn't strike me as being a good idea. But here's what we've got. So we've got that little bit of filtering circuitry, diode for polarity protection, we've got the 10 ohm resistor, and then we've got a capacitor that provides the filtered supply to the processor. The processor is only using 3 pins. The yellow pin is the here is the button being clicked to actually pull the that input to the negative rail, the 0 volt rail, which signals that the button's been pressed. The purple pin here goes over to the LED, which then goes to positive rail via a 330 ohm resistor just to light the LED. But the bit that's doing all the work, the orange pin goes via a 1K resistor, and it's got supposedly a 10K pull down resistor. They've used 9.1K just because that's what they had. And it goes to a MOSFET, a fairly decent MOSFET, a 60NO3L, which means 60 volts, 3 amps perhaps, and L means it's logic level, it's a low voltage. And then all these sockets here are all just basically in parallel, think powers up at once, with a little protection diode across it for clamping any inductive spikes and things like motors. So if you want to have a wee go at reverse engineering this yourself, here is the top of the circuit board. Oh, there's another thing. They've used these little connectors here, but then they used a screwdriver connector for the actual connecting the incoming supply. That's very strange, but here is the bottom of the circuit board, which is really just basically another bus for the negative rail, a bit of heat sinking attempting, and then the common positive going to all those connectors, and then the common switch going to all those connectors. Rightio, let's get the circuit diagram. Oh, I'll show you another circuit board. It's the LED circuit board. The LEDs draw 20 milliamps between them, so about 7 milliamps each. 470 ohm, they've actually lowered the value of the resistor. 2 LEDs in parallel for each of the 3 circuits, and then 1 resistor for each. Let's see if we can get the calculator in and work this out. So that's 5 volts minus, say, about 2.7 or something like that. 5 volts minus 2.7, that's just a rough figure, equals 2.3 volts to drop across the resistors, divided by 470 ohms, equals roughly about 5 milliamps. So the LED voltage across these must be lower, but so that is more or less, it's not a lot of current. They're token gesture LEDs, and it's not like ultraviolet. If they'd used blue, it would have been fairly bright, but they've used the ultraviolet ones, which means they're dim to start off with. It's very strange. They've also done that thing that they've left the edge on the circuit board there. I always get the urge to just snap that little grooved circuit board bit off. I'm going to do that just because I want to. They've V-grooved it. There we go. It's satisfying. And in the bin it goes. Right, in with this circuit diagram. It's not going to surprise you at all. It's very straightforward, oversimplistic. Makes you wonder why they didn't use a dedicated click on, click off type switch, or even the little dedicated chips that just do the on off thing. They've actually used a microcontroller for click on, click off. Very strange. We've got the 5-volt supply comes in, and there's the supply for the microcontroller, which is a diode, a resistor to limit the current, and then a capacitor. And that means that even if there's fluctuations in this rail, it acts like a little reservoir and it stops those affecting the microcontroller. Shame about the negative, but I'll maybe do a little experiment with that afterwards. There's the 330 ohm resistor going for the positive rail through the LED to the microcontroller. There's the push button bridging one of the connections to the ground. The output via the 1K resistor to the gate of the MOSFET, but also pulled down via this 10K resistor, 9.1K resistor to keep it off if that processor isn't active, or we'll just basically bias it towards off so it doesn't, if that crash, so it doesn't go into a sort of intermediate state. Then we've got the rail for those connectors. We've got the fan, the ultraviolet and the ion, and the little diode across them, and I've missed one of the dots. That's it. Right, tell you what, I am going to experiment now. I'm going to get the soldering iron on, and I'm going to remove that switch and see if I can actually see what the tracks are like underneath, and if just removing one pin from the switch, if the track doesn't go across, might solve that problem, but it might not. One option for solving their glitching problem, if it was still a glitch getting through here, would be to use a higher value resistor, because this thing's not actually doing an awful lot of current. Most of it's being pulled to the ground anyway, so that could have been a higher value resistor or a higher value capacitor, not sure what it is. Anyway, I'm going to pause, and then I'm going to get the soldering iron on. I'm going to put the soldering on right now, and I'll be back in 1 moment. 1 moment, please. Right, well, I've got the switch off. Let's do some experiments. So at the moment, I'm just going to bridge the switch contacts out with this just to see what happens. And it's still pulsing, right? Now, what happens if I unplug this and I cut the track that they've got here, because they've effectively got that separate negative going over to the chip, but then they've brought it over to the button, but then commoned it to the rest of the circuitry here, which you'd think, well, it's the same negative, but it isn't always the case. That if there's a high current path, it can actually cause a sort of voltage drop across the cable, across the track, and it can cause weird problems. So I'm just going to cut a little chunk out here. And I'm going to plug that in again and see what happens. Is that going to fix it? Because after this, the next culprit is the power supply itself. It's interesting how, though, it did actually work with the sort of higher output switch, the USB power supply. Is this going to solve it? No, that's not solved it. So next thing I'm going to try is a bigger capacitor across here, or I could try a bigger resistor. I'm going to try, I'll take that capacitor off and we'll see what value it is. 1 moment, please. Actually, no. I'll just, I almost swore there. I'll just do that technique. I'll disconnect it. And I shall just get that capacitor off by flooding a bit of solder on the other side and just wiping it off the circuit board like that. Let's see what value that is. Oh, it's still quite hot. Let's assume that even though it's tiny, it's going to be some ridiculously high value. And set this optimistically to 200 microfarad. It's well, I would say the closest standard capacitor value to that is, if I can get the probes onto it, this is the problem with these chips. 2 microfarad roughly. Okay, 2.2 microfarad. Right, tell you what, I'm just going to go and grab a 10 or 20, actually a 22 microfarad capacitor and stick it across that. 1 moment, please. So the capacitor has been changed. Let's try that. Nope, still pulsing. Right, next thing I'm going to do is try that resistor, and after that it's just maybe just going to be this thing has got a really high inrush current. It might just because it's got a little switching converter in it that initially draws quite a spike. Right, tell you what, I'll unplug that and get the solder and I shall slide that resistor off. I do have some surface mount resistors. So this is a 10 ohm resistor, which I've just flicked off. Right, what's my chance of actually managing to solder this on without stopping? Let's unplug everything. I'll look this out just in case. Let's go with the insulated tweezers here, the ceramic ones. So let's not get two resistors out at once. I got this because Julian Eyelet featured them in this little tiny flip-up component holder. It's quite handy. Very good for storing these, and you can stack them. So now, let's add a little squirt of flux to that huge mess of flux. I'll do it Paul style and add a big splooge of flux. I shall also perhaps, this is where it would actually be handy in a vise or something like that, but I don't really have something terribly handy. I should have wiped some of the solder off those. Just like I'm wiping all the flux off at the same time as well. Oh well. Right, let's get that 10 little resistor on there. Try and get that into place. This is where invariably when I'm doing these, every time I try just tweaking it and nudging it a little bit, it makes it worse. That looks okay. I think it might be the wrong size of resistor physically. I don't really know. It looks like a 1206. That's my preferred value of size of resistor surface mount, simply because they're bigger. So let that other end cool, and then I'll reflow this end. That's a 100 ohm resistor now, so that's going to provide a little more isolation. Let's plug everything back in, including this pesky ionizer module that's giving all the problems. And of course the ultraviolet LED has got to kill all those germs with ultraviolet. Run at very low power at a completely wrong wavelength. Wow, bitchy. Right. Is that going to make it more stable? Nope. It's just... I don't even know where to start with that then. That is a very odd problem. What comes to mind is actually putting a capacitor locally. Right, tell you what, one moment please. A capacitor, 100 microfarad capacitor, and what I'm going to do with it, I'm just going to put it across the supply that's coming onto the board to provide a little extra buffer, so that when the circuitry draws a spike, it doesn't cause the voltage to dip quite so much. By just acting as a little local reservoir, I shall flow a bit of solder onto these just to make it sticky. So, right, let's put that one there. Let it cool down, be patient. Put that one there. Is this going to solve the problem? Let's find out. So I'll plug that connector back in. I'll make sure I get the capacitor around the right way. Yes, I have. No juicy bangs. Okay, let's see if that acts as a buffer to keep the supply rail intact. No, that really is crap. I can hear things trying to start. Yeah, that's very odd. And it's all down to this little module here. That's very strange. If I unplug this module, the rest will work. Yeah, that's an unexpected problem. That would be very frustrating at the sort of when you're actually troubleshooting it, particularly if the design you used it with initially, you were maybe using a different module and it was less spiky. That's very odd. Not sure what avenue I'd go next after that. That is quite a tricky tricky one to resolve. Let me see if I did actually clear that. That's what I thought was the risk of providing alternative negative path that just basically provide a little glitch and crash the processor. Some processors are very easy to crash. I don't think it's the high voltage of the ionizer that's causing it, although that would be a suspect. Maybe I should turn the power off before doing this. I didn't. So let's turn that back off. Oh, actually no, let's plug this in while that's running and see if it crashes it. Yeah, it did. That is strange. That's super annoying. Maybe that module is cheaper than the others. No, it still is crashed. That is frustrating. But anyway, I'm not going to waste any more time on that because it's such a pile of crap anyway. It is without a doubt one of the weirdest. I mean, it's nice. It's got a solid. This weighs a lot. This is heavy. It's a heavy metal case. And it's nice that they've got a steel plate with the welded rods in it and then all these separators going up and down it. And it was obviously designed to be quite functional, pull the air through a filter and so on. Even if you can't change the filter, that's just frustrating. But it's been let down by so many things, basically speaking. The fan, where they punched the holes in the case, the point that the ionizer in the first place shouldn't really be used in an isolated supply because it does create that charge into the air that just creates the high voltage across the whatever USB supply you have. And then there's the ultraviolet germicidally LEDs that don't do anything and are just pointing down into the case, so you barely get a glimmer through the sort of like the holes in the top. And then the fact that ionizer brush, instead of being in the path, like being the path of this air vent to actually take a charge out, it's actually just stuffed into a little hole in this, which doesn't seem like a good way to actually to do it. It's just everything is wrong. It's a spectacular mess up. But you know what? There's a lot to be said for that. It's quite fun when you actually find products like this. So I wonder if this is a copy of something else, but certainly the description as being an ozone generator was wrong. It is an ionizer in a way, but it's absolutely terrible. It's an awful product, and that makes it most excellent.